Hey guys, welcome to the review video for Unit 7. There were only two things that people had asked for. One was topic 5, which is the graphing. So I've got both of the graphing ones. I'll do both of them. And there is topic 4, number 3. If you want another one, let me know sometime before 12:09 and I can make you an extra video over lunch. So when you are starting any problem in this unit, it is a good idea to factor. Down here, that's pretty easy because this one has three things with an x squared. So you just want to write two parentheses with x in them that have the two numbers that multiply to 8 and add to 6. That is 2 and 4, both positive. On the top, it's a little tricky because there's no x squared. And if you have two things without an x squared, usually it's a good idea to divide by the biggest number you can. So we've got 4 and 16. I can divide both of those by 4. So I put a 4 out front and then I put my parentheses. And inside for my parentheses, I'm going to write what is left if I divide both of these by 4, which gives me x, and 16 divided by 4 is 4. Now, what happens is you have these two that can cross out, the x plus 4 and the x plus 4. So we're going to go ahead and do that, but whenever you do that, it leaves behind something called a hole. And that hole is always going to be at the opposite of what you crossed out. It's called the zero of that factor. Since this was plus 4, this is automatically negative 4. Now, this is a point, and to find the rest of the point, we have to plug negative 4 in for x only into what's left. So when I cross those out, here's what I have left. To get the other half of the whole, you replace the x value with negative 4. And negative 4 plus 2 is negative 2. 4 divided by negative 2 is negative 2. So that's how you find the whole. Then I'm going to pull up my graph here. And I'm going to go right 4, 1, 2, 3, 4, down 2, and that's where my whole is. 4, negative 2. Notice how I drew an open circle because it's not a regular point, it's a hole. Then, for the x-intercept, you are going to set the top of the fraction equal to 0. The top of my fraction, though, is 4. 4 can't equal 0 because there's no x or anything up here. So there are none. And I'll explain why in just a second. The vertical asymptote is whatever makes the bottom equal 0. So the bottom of my fraction is x plus 2. So this is like if you solved the equation x plus 2 equals 0. You would then subtract 2 from both sides. That's negative 2. So I'm going to go to where x equals negative 2 and draw a line, a dashed line, vertically. That's what the V and VA means. V means vertical, up and down. Asymptote means we draw a dashed line because our graph is never going to cross this line. It sort of acts like a vacuum. Then for the y-intercept, that is where you plug in x equals 0. So that would turn this into 4 over 0 plus 2, or 4 over 2, which means that our y-intercept is 2. So you're going to go to the y-axis and put a point at 2. HA stands for horizontal asymptote. Over here to the side, I'm just going to write powers right now. And I'm going to write the two rules over here for the horizontal asymptote. I wanted to write same powers on top and bottom and different powers. So if you notice this one, whether you look here or here, there's an x on bottom but not top. There's an x on top, but there's an x squared on the bottom. That's different powers. That's always going to be y equals 0. If you have the same power, then you divide the numbers in front. And I'm sorry, I know that that got a little squished. So this says front. I'm going to divide the numbers in front. So if the powers were the same, I would divide these two numbers in front, which would be 4 over 1. But they're different, so it's y equals 0. Which means I'm going to go to where y equals 0 and draw a horizontal line. Like that. That is why there's no x-intercepts. It's because if that's where this dashed line is, there can't be any points here on the x-axis. And it looks like I made a slight mistake somewhere. Let me see if I can figure out where. Ha! My hole was at -4, -2. So it should actually be on this side for -2. And the part of the reason why I realized something was wrong is because I can't draw one here and here. So once you have two correct points, you draw a line through it that gets sort of like sucked into each side, like this, and you just kind of curve it around until it's getting really close to the asymptotes. There you go. Notice how I put each of these pieces over here as I found them. If you wait till the very end, it can be kind of confusing. Okay, let's do another graph. This one can factor on the top two numbers that multiply to 24 and add to 11. 8 and 3 multiply to 24 and add to 11. But in order to make them add to -11, I need them both to be negative. On the bottom, this is what we call a difference of squares, where there's no middle term. You can think of it like a 0x if you want, where you're trying to find the two numbers that multiply to -9 but add to 0, which is 3 and -3. You basically just do the square root of both of these, and you write one with a plus and one with a minus. Now, I can cross off the x minus 3's. That leaves me with a whole at 3. It was x minus 3, so the whole is at 3. And what I have left in my fraction is x minus 8 over x plus 3. So what I'm going to do is plug in 3 for both x's. And that gives me -5 over 6. When I go to put this on my graph, I'm going to do this correctly this time. I'm going to go over 3 and down 5/6, which is almost -1. Because -6/6 would be -1. Just make sure you go down, not up, because it is -5 over 6. Okay? And then I'm going to use the same rules as up here. For the x-intercept, the top part equals 0. So x minus 8 equals 0. If I were to solve this, I would add 8 to the other side. X equals 8. And I'm going to switch pins because it looks like this one's dying a little bit. Okay, so then I'm going to go put my x-intercept at 8. And 3, 4, 5, 6, 7, 8 is a little bit off of my graph, so what I'm going to do is draw a new one. That is a little bit more scooched over so that I can actually fit it on there. Okay, so I just kind of put that same point on here, but now I can go 3, 4, 5, 6, 7, 8. So now my x-intercept fits on there. Your graph won't have that problem. And then for the vertical asymptote, I'm going to set the bottom part equal to 0. You subtract that 3 to the other side, and you get -3. I don't know why I tried using it again. So then I'm going to go to -3 on my x-axis and draw my asymptote like this. And then my y-intercept is when I plug in 0 for x equals 0. So 0 minus 8 over 0 plus 3. I'm plugging 0 in for both of these x's the same way that I plugged in 3 for both of the x's. And I get -8/3. So I'm going to go -8/3 is almost -3. It's -2.66 on the y-axis. And then for my horizontal asymptote, that's my powers rule. These have the same powers on top and bottom, so you divide the numbers in front. Since there are no numbers in front, they are both automatically 1s, so it's y equals 1. So I'm going to draw a horizontal line up 1, like this. And then I am going to kind of include another part of a graph really quick. I want part of it to go off screen though, so that you guys can kind of see. This line is going to go like this, and the other line is going to be in the other corner. It's going to go kind of like this. 1 second. On the test, you will have a point over here to draw this one through, so you won't have to worry about just like randomly guessing. But it's either going to go here and here, or here and here. Okay, and I'll leave that up there so you can kind of take a glance if you want. Then I'll move on to the last one for the video. All right, let's talk about equations. So in order to solve an equation that has more than one fraction, if this was just like that, you would cross multiply. But what we want to do is try and get everything to have the same denominator. Before you can do that, you do need to factor this one. Like that. And then it is also a good idea to try and factor the top. You can divide those both by 4, kind of the same way I did the first graph in this video. And what you should notice is that you can actually cross off an x plus 7 on the top and the bottom. So really what I have left is this. This fraction just has a 4 left on top and an x minus 3 left on bottom. And now they all have the same denominator, so you can just say, hey, 6 plus x has to equal 4. It's kind of like saying you're multiplying this entire thing by x minus 3, and all of them cancel out on the bottom. And then I would just subtract that 6 to the other side, x equals -2.